All right, y'all, last thing, we're going to go over some quiz sections from 6.5 through 6.8. Okay? I didn't have 8 on here, but we'll do those as well. All right, check it out. Okay, when I look at this, I'm like, if the first thing I think is like, oh, u sub and u is 4 minus x squared, du is negative 2x dx, like because of that 4, that doesn't really work. But one thing I'm thinking is like, okay, this pattern, I kind of think of that as, oh, that's looking a lot like sine, inverse sine, which is 1 over the square root of a squared minus u squared. That's cool, except for that on the top, that doesn't really match that, that style or whatever. Okay, so actually this is a split up the fractions question. All right, where I'm going to do 4 over the square root of 4 minus x squared, and then I'm going to leave the negative x over square root of 4 minus x squared dx. Okay? Now, this is cool because on this side, give myself a little bit of room here, this is inverse sine form. Okay? That 4 can actually go out in front. U is x, that's fine. Du is dx, but a is 2. That's a big thing we got to remember because of this right here. A is 2, okay? So what this turns into is, okay, so there's a 4 outside, and then it's inverse sine of u over a. Make sure you put the little sign -1 or arc or whatever. That one's plus c, but this one's also going to be plus c, so I'll just put a big plus c at the end. Okay, so that's that one. Over here, this is a u sub problem, because if u is 4 minus x squared, du is negative 2x dx. That's why I left the negative there. So this turns into, let me do this over here, 1/2, and then it's 1 over the square root of u du. Now when I bring that up, that's u to the negative 1/2. So if I add 1, it's u to the 1/2 over 1/2, which is times 2 over 1. So that basically just gives me u to the 1/2. So this is 4 minus x squared to the 1/2, and then the whole thing plus c. So it's like 2 different problems, one with u sub and one in inverse sine form. All right, let's check out for 6.6. Now, you guys, this is giving me a piecewise function. It gave me equations for both. You can see that, like, this one, okay, is a upside down parabola, and then that's a right side up parabola, but it's giving me a piecewise function, okay? Sketch the graph, and then draw rectangles and do a midpoint setup. 4 rectangles of equal width. So my rectangles will go at 0, 2, 4, 6, and 8. Okay, I'm doing a midpoint right now. Well, the base of each rectangle is 2. And I just have to get the height of each rectangle. All right. Now, the first rectangle is going to have a height of whatever f of 1 is. The next rectangle is going to have a height of whatever f of 3 is. These are my midpoints, okay? That'll have a height of 5. And then that'll have a height of 7. Well, here's the thing, okay? For these two, f of 1 and f of 3, those are less than 4. I got to plug them in here. If I plug in 1, I get negative 1 plus 2 plus 9. That's 10. And if I plug in 3, I get negative 9 plus 6 plus 9. Okay? Now, for these two, f of 5, f of 7, I'm going to need to plug in here because those are bigger than 4. All right? If I plug in 5, it's, ooh, that's going to be ugly, 1/2 of 5 squared minus 7. Okay, if that's 25 over 2, I'm going to use 14 over 2. So it's 11 over 2. When I plug in 7, 7 squared is 49. So 49 over 2 minus 14 over 2, just to get a common denominator. That's 35 over 2. 1, 3, 5, 7. 4 rectangles. I put too many. Okay, there we go. All right. And so you guys, I have 20 plus 12. The 2's cancel out, so plus 11 plus 35. 46, 48, 58, 78. So I got 78 for that. Cool. By the way, if it's a free response question, you could actually stop right here. All right, you don't have to get all the way to the end. Okay, using the same function and same integral, show a right with 4 equal subdivisions. So you guys, the bases are still going to be 2. It's just that for my first rectangle, on the right, I pick f of 2. On the right, I pick f of 4. On the right, I pick f of 6. And on the right, I pick f of 8. Now again, these 2 and 4 will go up into here. 2 would be negative 4 plus 4 plus 9, so that's 9. F of 4 would be negative 16 plus 8 plus 9, so that'd be 1. And then for the other 2, I'm going to go into here. All right? If I plug in 6 squared is 36, half that's 18. 18 minus 7 is 11. If I plug in 8 squared is 64, half that's 32. 32 minus 7 is 25. Okay, and again, you could leave it like that. If it's multiple choice, though, I'm going to go ahead and add those up. So let's see, 9, 1, 11, 12. Yeah, so this is going to give me 18 plus 2 plus 22 plus 50. 40. That's me 92. Okay, there's my right Riemann sum. All right, nice. Let's see. New question for this one. Find a trapezoidal approximation. Subdivisions of 1, 2, 1 in that order. Okay, so the first rectangle will be 1. Next rectangle will be 2, and then 1. Okay, so 1, 2, 1. My first trapezoid is right here, and it's going to be 1/2. The base is 1, and the sum of the heights, which is 4 and 6. Okay, my next one from 2 to 4, 1/2. The base is 2, and then the sum of these heights, that's 6 and 1. And the last one is 1/2. That's a base of 1. And then the sum of the heights, which is 1 and 0. Okay, so I have 10, half of 10. 5, 2's cancel out, plus 7, plus 1/2. So I have 12 and 1/2. Or 25 over 2. Okay. Make sure we're good on that one. Perfect. Okay, nice. So that kind of covers Riemann sums, left, right, midpoint, trapezoidal. All right. You guys, when you see something that looks like a product rule, but it's for integrals. So a product rule for integrals, it's integration by parts, which is ultraviolet voodoo. Okay? So remember, we let u equal something. Let dv equal something. The dv is the thing that integrates really easy. Now, if I tried to integrate x, I'd get x squared over 2. That's more complicated. So I'm going to integrate cosine x dx, and so I'll let u equal x. Okay, so then I go, all right, du is 1 dx, and v, the integral of cosine, is sine x. All right, and once I get that all set up, it's pretty easy because I just go ultraviolet minus voodoo. Oh, thanks, X. Okay, so we're going to have x times sine x minus the integral of sine x and then du, which is dx. So that's pretty great. That's x sine x. Integral of sine is negative cosine plus c. And we're done. All right, perfect. So now let's take a look at number 2. We know that we can take the derivative of arcsine and arctan. We can't integrate those. So this is also a part, and it's because certain things like arcsine, we don't, and like ln of x you would use this for, we know what the derivatives are, we don't know what the integrals are, okay? So let u equal, let dv equal. Okay, so u is going to be actually this whole thing. And dv is just going to be dx, all right? Because I know that the derivative of arcsine is 1 over square root of 1 minus that squared. So I'll just go ahead and put 4x squared. And then v, it just becomes 1x, all right? So now if I do my ultraviolet voodoo, I get uv, so it's going to be arcsine 2x times x. I'm going to put the x in the front. Minus the integral of vx and then du. Okay, now the first part is done. I just have to work on this integral right here. And you guys, this is just a standard u sub question. It's going to be, okay, u is 1 minus 4x squared. Du is negative 8x dx. So I need a negative 8 and a 1/8. That turns into a plus 1/8. 1 over square root u du. Okay, that's u to the negative 1/2. If I add 1, that's u to the 1/2 divided by 1/2, or times 2. So my final answer is 1/4 u to the 1/2 plus c. U is 1 minus 4x squared. And then this side gave me x, arcsine 2x. Okay, so that was a kind of complicated one. Let's see if that's what we get over here. All right, perfect, that looks good. All right, I'm gonna just do the 6.8 questions right here. I don't have those written down, so we'll just do them. Okay, for number 1. When it factors on the bottom, we want to do, remember what's called partial fractions. A over x minus 3 plus b over x plus 2 equals x plus 7 over x minus 3, x plus 2. And what I do is I multiply everything by basically x minus 3, x plus 2. You can do it. This is a faster way to do it. Okay, so look at what happens. Right here, the x minus 3's cancel. So I just have a and x plus 2. Right here, the x plus 2's cancel. So I have b and x minus 3. And right here, everything cancels, and I just have x plus 7. And then we're going to do this little trick, okay? We're going to do this little trick where we say, first, let x equal whatever will make that 0, negative 2. So when I do that, a times 0, that's 0. I get b times negative 2 minus 3, negative 5 equals negative 2 plus 7. So b times negative 5 equals 5. So b is negative 1. Then I'm going to let x equal whatever will make this one 0. And x minus 3 it would be if it was 3. And I'm going to do this equation again. I'm going to go a times 5, b times 0, so that would go away. A times 5 equals 3 plus 7. So a times 5 equals 10. So a is 2. So I can rewrite this now as 2 separate fractions. A is 2. B is negative 1. And my final answer will look like this. 2 ln x minus 3 minus 1 ln x plus 2. plus c. Okay? All right, so that one's called partial fractions. Okay. Let's see here. Number 2. Now, if this were a plus, it would be inverse tan form. But it's not, it's a minus. Also, it factors. Okay, so I can tell that because this factors to x plus 3, x minus 3, I can do partial fractions. Here's my partial fractions. A over x plus 3 plus b over x minus 3 equals 9 over x plus 3x minus 3. And if I multiply each term by x plus 3, x minus 3, a is left with x plus 3, b is left with x minus, or sorry, a is left with x minus 3, b is left with x plus 3 equals 9. So I've got to just do let x equal 3 for the first one, let x equal negative 3 for the second one. Okay, if I let x equal 3, that's 0. So b times 6 equals 9. So b is 9 over 6, 3 over 2. If I let x equal negative 3, b, that one's 0. A times negative 6 is 9. A is negative 3 over 2 when I reduce that. Okay? So let's go back to the beginning right here. Split that up into my partial fractions. So I'm now doing the integral of, okay, a was negative 3 over 2 over x plus 3. B was regular, positive 3 over 2 over x minus 3. All right, and then my answer for that one's pretty easy. It's negative 3 over 2 ln plus 3 over 2 ln plus c. Okay, so that was for number 2. And then, oh yeah, that's good. And then, okay, let me do fit number 3 right here. Okay, this one is the integral from 1 to e of 1 minus ln x over x. Now, I could split this up because there's one term on the bottom. Do I need to, though? I think I can just use u sub. I might not need to split this up. Let's see if I can do u sub. I can, because the 1 will go away, and the derivative of negative lx is negative 1 over x dx. So I just have to have a negative there, which means there's a negative on the outside. So then it's just negative u, and then all of that turns into du. So this becomes negative u squared over 2. Now, I want to change my endpoints, so watch carefully how I do that, okay? If I plug in e, the ln of e is 1, 1 minus 1 is 0. If I plug in 1, the ln of 1 is 0, 1 minus 0 is 1. So I have negative 0 squared over 2 minus negative 1 squared over 2. So I end up just getting 1/2 for that. All right. Perfect. Okay. Couple more problems from 6-8. Let's add another page down here. Here we go. How do I add a page? Add a page. Yeet. Okay. So still continuing from 6.8, this was 6.8b, I have 4 over x squared minus 4. I have 4 over the square root of 4 minus x squared. I have x to the third over x squared minus 4, and I have 4 plus x over x squared plus 4. This is an incredibly good set of problems. It's really going to make me look at the different types, okay? Okay, number 2, I feel like that, because it's a square root of a square minus a square, that's going to be inverse sine form. Number 3, I feel like might be long division. because it's the degree top bigger than the bottom. I feel like that's going to be long division. Number 1, I believe, is going to be partial fractions, because that splits up. And then number 4, what I think I'm going to have to do is split it up and then do an inverse tan form and a u sub. That's what it looks like. Now, we got to practice to where you guys are looking at this and going, okay, I know what I'm supposed to do on each question. It's kind of the hardest part. So that was something I was hoping we would practice today. All right, let's look at number 1. How did I decide that it's partial fractions? Well, because this factors to x plus 2, x minus 2. If the bottom factors, that's typically what we want to do, okay? A over x plus 2, b over x minus 2 is 4 over x plus 2, x minus 2. Multiply everything by x plus 2, x minus 2. I get a x minus 2, b x plus 2 is 4. I'm going to let x equal 2 for the first part, let x equal negative 2 for the second part. Okay, if x is 2, that goes away. B times 4 is 4, so b is 1. If x is negative 2, a times negative 4, that goes away, equals 4. So a is negative 1. Okay, so my integral changes to, let's see, negative 1 over x plus 2. I'm kind of referring back to here, which was which. Negative 1 over x plus 2. And positive 1 over x minus 2. And then these both become ln's. Negative ln x plus 2. Positive ln x minus 2 plus c. Remember, I told you on a multiple choice question, they might actually just put this together and put x minus 2 over x plus 2. Because when you're subtracting 2 ln's, you're actually dividing. Okay? Let's see. Yeah, I like that. Good. All right, let's check out this. This looks like inverse sine form to me, because I can take this 4 out. And then I can say, okay, u is x. Sorry, not x squared. Du is dx, and a is 2. So if I take the 4 out, it's the inverse sine of x over 2 plus c. Okay, so that's just like kind of memorizing that formula. Number 3, the reason I think that this is long division is because top is bigger than the bottom. So let me do long division on here. Okay, long division goes like this. X squared goes into x to the third x times. Cancel, cancel, or change the signs, that cancels. And then I have a remainder of 4x, which means that this equals, okay, whatever I got for my long division, x, and then the remainder over the divisor. Okay? Now, I can go ahead and split these up into 2 separate integrals. The integral of x is x squared over 2. The integral of this is going to be u sub. Okay, this part, you guys, is going to be u sub. U is x squared minus 4. Du is 2x dx. So to change that 4 to a 2, I do a 1/2 and a 2 on the outside. Okay, so this becomes 2. The integral of 1 over u du. Okay, which is ln u. My pen is acting funny. Which is ln u. But of course, we got to get everything back into x. So it's 2 ln x squared minus 4 plus c. Okay, perfect. All right, and then let's go ahead and look at number 4. Yeah, we're going to go ahead and split this up, okay? And we're going to split this up to, okay, I'm going to go 4 over x squared plus 4. I'm going to go x over x squared plus 4. All right. This one is an inverse tan form, where u is x, so du is dx. A is the square root of 4. A is 2, and that goes out. So it's, the 4 is on the outside, and then it's 1 over a inverse tan u over a. Okay? This is going to be, this side is going to be u sub. U is x squared plus 4. Du is 2x dx. 2 1/2. So then that's 1 over u du. So that's 1/2 ln u. And so that's 1/2 ln x squared plus 4. All right. Nice. Okay, last two questions. These are called improper integrals. It's where it has either an integral sign on one of them, or like the problem with this one is there's an asymptote at 1, and so it's one of the sides, the endpoint is going to an asymptote. Okay, basically, you guys, we just have to set this up as a limit. We just have to go like this. The limit as b approaches infinity of 0 to b. Okay? Cool, cool. All right, I'm going to let this be u substitution. All right, and so I get the limit as b approaches infinity, the integral of 1 over u du, which is ln u, which I can then plug back in ln of 1 plus e to the x. Okay, and I'm evaluating this, you guys. I'm back in terms of x's, so that's fine. I'm evaluating this b to 0. Now I evaluate it. You don't do this limit till the very end, okay? So if I plug in this b, it's the ln of 1 plus e to the b minus the ln of 1 plus e to the 0. Now here's the problem, okay? As b goes to infinity, that goes to infinity, and the ln of that goes to infinity. So this goes to infinity. I can't figure anything out. We just say that diverges, and we can't do the problem. Okay? So, number 1, it diverged. We're not able to do that. Now let's look at number 2. All right. I can see that the problem is right here. I have a vertical asymptote at 1. So what I need to do is the limit as a approaches 1 from the right, because from 1 to 5, those are numbers to the right of 1. And then I need to do the integral from a to 5 of this. Okay? Well, this is like, I mean, it's kind of u substitution. I'm not going to write all of it down because it's just an x minus 1, so it's not going to change anything. Anyway, to the negative 1/2 would be x minus 1 to the positive 1/2 times 2. Evaluated 5 to 8. All right, negative 1/2, add 1, positive 1/2. Okay, that's good. So this is the limit as a approaches 1 from the right of 2, and then when I plug 5 in, that's 4 to the 1/2, and then 2a minus 1 to the 1/2. At that point, okay, 4 to the 1/2, square root of 4 is 2. 2 times 2 is 4. And if I plug in a from the right, that actually goes to 0. So that one I can find an answer for, and the answer is 4. Whew, that was a lot of calculus, guys. Hope you're feeling all right.